Hello everyone. In this video, we're going to determine the inverse of exponential function, and this is the first part. Before we go through this example that we have right here, let's have a review on how to convert exponential form to its equivalent logarithmic form. Please remember that we can change an exponential form to its equivalent logarithmic form following the general rule right here. This base that we have here is going to go to the base of the logarithmic expression. This exponent that we have here, exponent m, will become the value of this whole expression that we have on the left. And this a that we have here will go to this part right here, which we call as the argument. This is how we change a given exponential form to its equivalent logarithmic form. Okay, going back to the example right here, we're supposed to determine the inverse of this function f of x is equal to 3 raised to the power x minus 2. There are steps that we need to follow in order that we can determine the inverse of this function. The first step is to replace f of x with y. So this f of x will become a y, and so I'll just copy the rest of the other expression on the right side. Okay, now we're ready to move on to the second step. The second step states that we are supposed to replace every x with y and every y with x. We are supposed to isolate the exponential expression on one side of the equation, and we convert this exponential expression to its equivalent logarithmic form, and we solve for y. So in this case right here, we are supposed to replace the y with x. So this becomes an x, and that is equal to 3 raised to the power y minus 2. So we are supposed to isolate this exponential expression. So it's already isolated. So then we go ahead and convert this to its equivalent logarithmic form. Now we remember that if we are given an exponential form, y is equal to b raised to the power x, we can change that to its logarithmic form. We can have this as log of y to the base b is equal to x. So that's how we put those variables into the logarithmic expression, so that we can go ahead and say that this equation that we have here, if we want to change this to its logarithmic forms, I'm just going to go ahead and say log, and then we put the parentheses here. This will be for the base. The base is 3, so I write the 3 here. And then this is equal to the exponent of the exponential form, so that is y minus 2. And this is our argument, which is the x value that we have right here. So this is the x right here. So that we go ahead and solve for y. Because again, inverse is we are supposed to, part of the second step is to solve for y. So that we can go ahead and say that the y goes with minus 2 right here. So all we need to do is to add 2 to both sides plus 2 here, so that we can cross the 2 out. So we are left with... Okay, so we already have isolated the y, and y is actually equal to log base 3 of x plus 2 is equal to y. Now we're ready to move on to the third step. The third step states that we are supposed to replace the y of the equation solved in step 2 with f negative 1 of x, so that the final notation for the inverse here would be f negative 1 of x is actually equal to, that's gonna be log of x to the base 3 plus 2. So this is the inverse of this given function that we have up here. On the side, you will see the graph of these two functions here on Desmos. The one in red is the function which is y is equal to 3 raised to the power x minus 2, while the one in blue is its inverse, which is equal to log of x to the base 3 plus 2. You can see that these two graphs are actually symmetric with respect to the line of symmetry y is equal to x, which means that if we fold this graph along the line y is equal to x, the one in broken line, they're gonna match up. This tells us that these two graphs here, or these two functions, are inverse of each other. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, we're supposed to determine the inverse of this function f of x is equal to 1/4 parentheses 2 raised to the power 3x plus 1 minus 5. Again, there are steps that we need to follow in order that we can determine the inverse of this given function right here. The first step is to replace f of x with y. So this becomes our y, and then we keep the rest of them here. Okay, after that, we're ready to move on to the second step. The second step states that we're supposed to replace every x with y and every y with x. We isolate the exponential expression on one side of the equation, and we're supposed to convert the exponential expression to its equivalent logarithmic form, and we solve for y. So in this case right here, this becomes the x and this becomes the y. So I'm just going to go ahead and rewrite this. Okay, so what I did was I changed the y to x and then the x to y. And then part of this step is to isolate this part of the equation. But then we got the 1/4 and we got the minus 5. So all we need to do first is we are going to add 5 to both sides. So we can get rid of the 5. So plus 5 and plus 5. So this would come out, that's going to be x plus 5 is equal to 1/4 2 raised to the power 3y plus 1. We still have the 1/4. Now we can get rid of the 1/4 by multiplying its reciprocal. So we're going to multiply this by 4, and we multiply the other side by 4 as well to make them even. So then from here, we can go ahead and cross out the 4 and 4. So then we can distribute the 4 to each of the terms inside the parentheses. So that would come out 4x plus 20. And that is equal to, so the 4 and the 4 gets crossed out already. We are left with 2 raised to the power 3y plus 1. So then part of this second step is to convert this exponential form to its equivalent logarithmic form. Now we remember that if we are given an exponential form, y is equal to b raised to the power x, that is actually equal to log of y to the base b is equal to x. So in this equation that we have right here, we can go ahead and change this to its logarithmic form. So I'm just going to go ahead and write the log. Okay, the base is also the base of the logarithmic expression. So I put the 2 here. This exponent will go to this side of the equation. So that would be 3y plus 1. And then this becomes the argument, that's 4x plus 20. So then part of the second step is to isolate y by itself so that we can go ahead and I'm just going to go ahead and rewrite this up here. So that we can isolate the y by itself, we're going to subtract 1 from both sides. So I'm going to subtract 1 from both sides right there. So we can go ahead and cross the 1 out. We are left with okay, since we want y by itself, so then we are going to divide both sides by 3. So I'm going to divide this whole thing by 3 as well, so we can cross the 3 out. So we are left with now, since we isolated the y by itself, we can go ahead and move on to the third step. The third step states that we are supposed to replace the y of the equation solved in step 2 with f negative 1 of x, and that will represent the inverse. So then we can go ahead and finally write this as f negative 1 of x is equal to, that's gonna be log of 4x plus 20 to the base 2 minus 1 over 3 is actually the inverse of this function that we have up here. So I'm just going to put this inside the box. On the side, you will see the graph of these two functions, the inverse and the given function. The given function is in red, which is 1/4 parentheses 2 raised to the power 3x plus 1 minus 5. And its inverse, which is log of 4x plus 20 to the base 2 minus 1 over 3. You can see that these two graphs are symmetric with respect to the line of symmetry y is equal to x, which means that these two graphs are actually inverse of each other. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!